Hi viewers, welcome to the next section of the course, Communication between Threads. In this section, we'll learn the standard data structures in Python and how we can interact with them in a thread-safe manner. Then we'll explore thread-safe communication using queues and how we can effectively use these queue objects. Post that, we will discover double-ended queues and how they differ from traditional queues. Lastly, how we can utilize all of these new concepts and build our own multi-threaded website crawler. Let us begin with the first video of the section. Sets and Decorator. In this video, we'll take a look at a few examples of locked set function, decorator, and class decorators. During my time working with communication between multiple threads in Python, I discovered that one excellent solution to use sets in a thread-safe manner is to actually extend the set class, and to implement my own locking mechanism around the actions that I wish to perform. If you are used to working in Python, then extending the class should be a somewhat simple operation. Let's take an example and create a new document, and name it as lockset.py. Then add the code snippet in this file. Here we define a locked set class object, which inherits from our traditional Python set class. Within the constructor for this class, we create a lock object, which we'll use in subsequent functions in order to allow for thread-safe interactions. Below our constructor, we define the add, remove, and contains functions. These rely on the superclass functionality with one key exception. With each of these functions, we use the lock that we initialized in our constructor to ensure that all interactions can only be executed by one thread at any given time, thus ensuring thread safety. Next, look at the decorators. One of the other key methods that we could leverage is to utilize decorators. With this mechanism, we define our decorator method, locked method, which takes in a method. This decorator method will then define a new method within it, and call the original method only when it has acquired self-lock. Let's take an example for decorators. Creating a new file, we will name it as decorator.set.py and add the code snippet in this file. In this example, we implement our decorator method that returns a race condition protected version of our passed-in method. Moving further is class decorator. Class decoration takes our previous example one step further, and instead of protecting one single method, we can protect every function within our class, so that all calls are done in a thread-safe manner. In this example, we look at how we can implement a class decorator function. The lock_class function at the start takes in a list of methods and lock factory, and returns a lambda function, which takes in the method names specified in the decorator as well as lock factory. This calls makeThreadSafe, which initializes an instance of our passed-in class. It then defines a new constructor which also calls self-lock equals to lock factory function. This makeThreadSafe function then iterates through all of the methods in method names and locks each method using the lock method function. This represents a clean and easy way to add thread safety to an entire class, while also giving us the option to choose which functions we wish to lock. That's all about class decorators. Great! In this video, we have learned the concept of sets decorators and class decorators with its respective examples.